We are going to study about the karst landforms. Okay, so let's study about the karst landforms. What are these karst landforms? So the karst topography is named after the typical topography which developed in the limestone rocks of karst region in the Balkans adjacent to the Adriatic Sea. Okay, so the karst landforms, also called as karst topography, and that developed in the adjacent area of the karst region of the Adriatic Sea. Okay, near the Adriatic Sea in the karst region. So this is the name, karst is the name of a region near Adriatic Sea. Okay, so in this region the topography developed, so that is why this topography, this type of topography is called as karst topography. Okay, now karst topography includes typical landforms in any limestone or dolomitic region, so produced by the action of groundwater through the process of solution and deposition. So the limestone is an organically formed sedimentary rock. Now you should remember mainly the karst topography that takes place in the limestone area, the area which is made up of limestone, the rocks which are made up of limestone. So the limestone is an organically formed sedimentary rock. In its pure state, limestone is made up of calcite or calcium carbonate, but where magnesium is also present, it is termed as dolomite. When magnesium is present in the calcium carbonate, that is in the limestone, it is called as dolomite. So limestone is soluble in rainwater. Remember this, because this is the feature because of which this is responsible, because the limestone is soluble in rainwater, and this is the reason the karst topography is taking place. Okay, so what are the conditions for the karst topography to take place? So a region with a large stretch of water soluble rocks such as limestone at the surface or subsurface level. So the first condition for the karst topography to take place is that that region should be consisting of the limestones. Okay, that should have the rocks which are made up of limestone at surface or subsurface level. Now the limestone should not be porous. The water should not go away directly inside the from the rock. It should not be porous. The rocks should be dense, thinly bedded and well jointed. The rock should be dense, thinly bedded and well jointed. So these are the three conditions. Okay, so that the water is not going directly not going directly from the cracks. Okay, so for that purpose it should be thinly bedded and well jointed. So a perennial source of water and low water table to allow the formation of conspicuous features. Okay, that is, the perennial source of water should be there and low water table should be there to allow the formation of this karst topography, and moderate to abundant rainfall to cause the solvent action of water, that is solution of rocks. So what is the mechanism of actually the karst region? Okay, the erosion of karst region. So in karst regions, rocks are permeable, thinly bedded and highly jointed and cracked. Thus there is the general absence of surface drainage, as the surface water has gone underground. After vertically going down to some depth, the water under the ground flows horizontally through the bedding planes, joints or through the material themselves, and rocks are eroded due to this downward and horizontal movement of water. It is through the chemical process of solution and precipitation, deposition by surface water and groundwater. Varieties of landforms are developed in rocks like limestones or dolomites rich in calcium carbonate. What do you understand by this? I will tell you, don't get confused, don't get worried. So let me explain. First, we will see that there are two types of landforms, erosional and depositional. Okay, so see, there are rocks. These are the rocks made up of limestone. Water is falling on this, and when water is falling, so this is a huge surface of limestone rocks. When water is falling, it starts to seep down through the rocks, the limestone rocks. These are the limestone rocks, and as you know, the limestone rocks get dissolved in the rainwater. So when the water is falling on these limestone rocks, the water starts to seep down, and when the water starts to seep down, it makes a way and it goes down. So when it goes down, it will take along with it all the limestone with it, and it will create different features here inside underground. Okay, this is underground. So it will create different types of feature. Why? Because now the rocks, the water has seeped down into the rocks and it has gone inside, and here it has created different type of features which we are going to study in our lesson. So here we will find there are two types of landform, two types of features, erosional features and depositional features. So the erosional features are the sinkholes, the uvalas, the caves and the polychaes. Okay, and the depositional features are the stalactites, stalagmites and pillars. Now let's see how does this look. So sinkholes, so here is the swallow hole in section. The river, the water is falling here, the water is falling here and it is seeping down. It is seeping down and it is taking away with it the limestone. Okay, the limestone is eroded by the water. The limestone is eroded by the water and it will further develop into the sinkhole in section. Okay, this will turn into this slowly and steadily. Slowly and steadily this will turn into this. This is the limestone, remember. And limestone gets dissolved in rainwater. These are two important things you should remember. Now the swallow hole is turned into the sinkhole. Okay, and now later on this sinkhole, it will get collapsed. It will be collapsed and it will create a cave, and water will straight away flow in this directions. Okay, now here are the sinkholes. This sinkholes will look like this. Okay, so here you can see the collapse of sinkholes. Here you can see the collapse of sinkholes. This is the collapse of sinkholes and water is flowing. So when the water is flowing, you will find here also there is water and water is seeping down. Okay, water is coming down, and when the water is coming down, it will bring along with it the calcium carbonate. Okay, the water is seeping in the downward direction. In this direction the water is seeping, and along with it, it is bringing calcium carbonate with it, and it will get deposited in this. Okay, here it will get deposited on the roof of the cave. So this is the cave. This is actually the erosion. Here actually it was filled up of the limestone, but later on the limestone got eroded due to the water is flowing. So here you can see this type of features are developed due to here the water is dropping down, and when the water is dropping down, that time you will find this type of structures are formed. So these structures which are formed due to the seeping of water and deposition of calcium carbonate. So these structures are called as stalactites, which are from above. Okay, so these are called as stalactites. And now say at the same time, when the water is falling down, that time also the calcium carbonate will get accumulated here on this part. Calcium carbonate is accumulated. So this we will call as stalagmite. So the upper portion is called as stalactite, the lower portion is called as stalagmite. Okay, very simple. But after a while, this will get mixed with this. Okay, and it will convert into a pillar. The deposition and accumulation of the calcium carbonate will go on increasing, and later on it will get converted into a pillar once it is joined. So the stalactites are from above, stalagmites are from below, and later on the stalactites and stalagmites, when they merge together, they will form a pillar. Okay, here you will find this is the cave mouth, where the water is flowing, the seeping water, it is flowing. Okay, so this is all called as karst topography. Now remember, the story started from the sinkholes, from the swallow hole. So earlier there were a small depression like this. Okay, and the small depression got converted into a sinkhole like this. Here you can see these are also the sinkholes. The swallow hole got converted into sinkhole. And remember, mind you, this is all this is the limestone, and limestone is easily dissolved in the rainwater. So earlier there was a swallow hole, a small depression, it got converted into the sinkhole. Now the sinkhole collapsed, and this type of structure was formed. Then again the seeping was going on, and along with this seeping, the above side also the calcium carbonate was deposited, and at the same time calcium carbonate was deposited here also on the downside, and later on these two merged to form the pillar, and later on the water which flow down, it is called as cave mouth. And when this sinkhole merged with each other, here you can see, if they merge with each other, they will fall. Okay, there will be a collapsing, and it will form a valley sink or ovala. Like if this pillar is removed, if this pillar is if this pillar falls down, it will create a valley sink, this type of structure, or uvala, you can call it uvala. So if this whole structure, if it falls down, now if you can see this whole structure is standing on a single pillar, here you can see, and this whole structure, when it falls, you will find valley sinks or uvalas. So this is the karst topography which developed in the Karst region near the Adriatic Sea. Okay, so this is all about the karst topography. In our next lesson, we are going to study about the glacial landforms, the landforms which are made by the glaciers. Okay, so